Okay, in this video, we are going to be doing an AP Calculus midterm review. I'm calling it potentially part one. Potentially because part one took forever to make, as you can see by the length of it. But I do think there are a couple of gaps, notably the mean value theorem. I'd like to do a couple more optimization things. But otherwise, I think this is a very good review. And if you're studying for the AP exam, I think it would also be helpful. And I hope you find everything in this helpful, and let's get started. All right, let's see if we can solve these problems. So I'm gonna be bouncing back and forth between my iPad and my Mac, and I don't usually do that, so hopefully this goes well. And I couldn't find a little calculator icon, so I put this little dolphin-looking thing on any problem that I think I'm gonna need a calculator for. So let's see if we can do this. So what is the slope of the line tangent to the curve y equals x to the cosine of x at x equals 0.3? I mean, this is a straightforward, just use your calculator, but let's show the work. So we want d dx of x to the cosine of x, and we want to evaluate that at x equals 0.3. That's going to approximately be something. I'm going to try to remember not to constantly put that back there, although I think I probably will. All right, so I got to go to a calculator, and let's do this. So I'm in radian mode, and I want the derivative. So I always do it this way. This is not the most efficient way. X to the cosine of x, and then I need such that, which is going to be control equals 1 to the left, x equals 0.3, and I get this. I'm going to jot that down. So 1.121, because you want 3 decimal places. So the best way to do it is to do menu, option 4, and then derivative at a point. So that's option 2. X is the variable, 0.3 is where I want it, and then you would just put in this. And there we go. So we get the same answer either way. But that, I think, is how we'd want to do it. All right, I'm going to go do the next one. Let's see. So back to this. This is going to be another calculator question. If f of x is the natural log of the cube root of x plus 8, then approximately what is the average rate of change of f of x on 1 to 4? So average rate of change is algebra 1 slope. So we're going to start with that. So f of 4 minus f of 1 over 4 minus 1, which will approximately be something. And obviously, I got to go back to the calculator to get that. So let's see. So I'm going to do, I guess I'll define it, f of x, and then colon equals is control, and then this guy. Natural log of, I'm going to do to the 1/3 because I don't like using the cube root template. 1/3. Okay, so this is f of x, and I need to do f of 4 minus f of 1 over 4 minus 1. There we go. All right, so let me put that down. 0.31, no, 0.032. All right, so average rate of change is algebra 1 slope. That's kind of a big deal. You're going to run into it quite a bit, I would say. It's on almost every AP exam in kind of like multiple locations. So what is the y-intercept of the line tangent to the graph of y equals 3 to the x minus 2 at x equals -1? I'm going to do this without a calculator, but then the answer is just ridiculous. I think as I was practicing to see if I could pull off what I'm trying to do here, I actually did this problem, and I was like, I don't know, maybe this actually should be a calculator problem. So let's see. If I were doing it without a calculator, I'd first figure out the y value, right? So y of -1 is just 3 to the -3rd. Now I need the derivative, so let's find, I'm going to call it y prime. Y prime is the derivative of a to the u is going to be a to the u natural log of a times the derivative of u. So it's going to be 3 to the x minus 2, natural log of 3, and then times 1, which, like, we don't need times 1, but okay. So then y prime such that x equals -1. It's really annoying that this little like scroll bar left and right, I think, thing keeps, actually I'm not sure if that's that. That might be like the dock or something for my iPad popping up. Yeah, that's definitely what it is. I don't know. I probably should have turned that off, but I didn't. So this would be 3 to the negative third natural log of 3. And so then our tangent line would be y minus 3 to the negative third, which is 1 over 27, but like I don't think that's going to really help me here, equals 3 to the natural log of, nope, 3 to the negative third natural log of 3, and then x plus 1. Okay, and then I need to find the y-intercept of that. So y-intercept is when x equals 0. So y-intercept is going to be y equals 3 to the negative third plus 3 to the negative third natural log of 3, and then x is 0, so we just get that. I don't know. I mean, I guess we could just leave that. The only thing I would do is get a decimal. It's got to be a really small decimal. But I'm going to write it as an ordered pair because I don't know what the expectation would be. Here we go. And then you could definitely use a calculator to get that. All right. So, so far that's 3 questions. All of them were calculator. Let's see what is next. I'm going to try to do this all, I don't know. I was going to try to do it all in one continuous take, but I might actually end up splitting that up because when I mess up, it'll just be easier to edit if I haven't made one long video. So if y equals k is tangent to y equals x squared plus 4x plus 2k, what are all possible values of k? All right, so this is a horizontal line. And since it's a horizontal line, we know that y prime will be 0. So I'm going to find y prime and set it equal to 0 and see if I can solve that. So 2x plus 4. That's just power rule. So if that equals 0, then x will be negative 2, right? Minus 4 divided by 2. And then if x is negative 2, what do I do with this? Oh, okay, I got it. So we also know that like y is equal to k. That's gross. Do I have a better highlighter for this particular color? Not really. Whatever. I'm gonna undo that. Okay, so if y is equal to k and y is equal to this, then we have that k is equal to so k is equal to, I'm gonna let this happen. Negative 2 squared minus 8 plus 2k. Okay, I feel pretty good about this. So then negative k is negative 4. I think that k is 4 in this case. Does that make sense? I guess so. I don't know. I mean, it's the vertex, right? So we could check this if we wanted to. I would say like if I were taking a midterm, I would not check this, but if we had y equals x squared plus 4x plus 8, what am I looking for? I guess the vertex would be what I would want, right? So we know that that's when x equals negative 2, because that's what we found. So then y is going to be 4 minus 8 plus 8. So y is equal to 4 is the so the vertex, what am I even doing? I'm checking, right? So is negative 2, 4, and we know there's a horizontal tangent line at the vertex of a quadratic. So I wouldn't have bothered to check this, I don't think. That's a pretty interesting, good question. Let's look at the next one. So if y is equal to x squared, if y equals x squared is tangent to y equals negative x squared plus kx minus k, find the possible values of k. All right, so they're tangent to each other, which means they must intersect. I mean, we have kind of a this, and I don't really know, like this type of situation happening. They're tangent, and if they're tangent, they must have the same slope at the point of tangency. So I'm going to set them equal to each other, and also I'm going to set their derivatives equal to each other, and I think that's what I need to do. So To make them hit each other, I would need x squared to equal negative x squared plus kx minus k. And then I also need their derivatives to be equal. So for this, I get 2x, and for this, I get negative 2x plus k. Okay, so what are we doing? We want to solve this like system of equations, I guess. And I guess from this equation, I know that 4x is equal to k. And do I want to solve for, yeah, so 4x is equal to k. So I'm just going to take this, and everywhere I see k, I'll replace it with 4x. And see how that goes for us. So that'll give us, coming down here, x squared is negative x squared. So k is going to be 4x, so plus 4x squared, and then minus 4x. And remember, we want to solve for k, but I seem to be solving for x right now. 3, 2, so I think we get 0 is, so on this side, do I have like a thing? Oh, I do, I have like a laser pointer. Okay, so this combines to 3x squared, then I'm going to subtract another one, which gives me only 2x squared. 2x squared minus 4x. I'm going to factor x out. We're getting multiple k's here. 2x, x minus 2. So then either x is 0 or x is 2. But remember, we need to solve for k, and to get k, I have k is equal to 4 times x. So if x is 0, then k would be 0. And if x is 2, why would I write x again? K would equal 8. So I think these are our answers. We either get gross or gross. Gross because the highlighter is a disgusting color. All right. Not bad. Let's take a look at the next one. Apparently, there's a lot of this. The line y equals 5x minus k is tangent to the graph of f of x equals 4x cubed plus 2x. What are the possible values? I think this is the same basic idea, so I'm going to do it again. See how it works. So I'm going to set them equal because if it's the tangent line, then it must hit the curve. So like, I mean, we can kind of sketch something, like there, right? So they're definitely going to hit each other. So one equation will be 5x minus k is 4x cubed plus 2x. And then also their derivatives should be equal because they should have the same slope. So if I find the derivative of this, it's just 5. And then the derivative of this, it's 12x squared plus 2. Okay, so then 3 is 12x squared. And then x squared is 1/4. So x is plus or minus 1/2. And then we're looking for, so if x is plus or minus 1/2, we are looking for the values of k. All right, so I have an idea. I'm going to end up using this relationship where if I knew x and I knew y, I would be able to solve for k. Over here, if I know x, I can figure out what y is. So because of that, I'm having trouble imagining, I guess I was having trouble imagining like the geometry of this, where this could happen, but I guess like maybe there's two different lines, right? Like one line is here and then maybe the other line is here and they're just parallel to each other. So like the different k values give me different lines. That makes sense because it's basically kind of the opposite of the y-intercept that we're finding. All right, I'm not confused anymore. Let's solve this. So f of 1/2. Ooh, I hate that. There's like some gesture that I do that undoes stuff. I don't exactly know what it is, but it's really similar to when I make a 2. And it just erases 2's that I make sometimes, and that's not great. This will be 4 1/8 and plus 1, so 3/2. Okay, so my ordered pair is 1/2 3/2. Then I'm going to go here, and I'm going to plug in 1/2 3/2 and solve for k. So it'll be 3/2 is 5 times 1/2 is 5/2 minus k. So that means that negative k is negative 2/2, negative 1. So k is 1 in that case. I bet k is -1 is the other answer, but let's actually find it. So we're going to do the same thing. F of -1/2 is going to be 4 -1/8, because when we take -1/2 and cube it, we get -1/8, and then -1. So that's -1/2 minus 1 is -3/2. So our ordered pair is -1/2, -3/2. And then I'm going to do the same thing. I'm taking the ordered pair, plugging it in here. So this problem is a little more involved maybe than the last one. I don't really know. I think it's a little more involved. -3/2 is -5/2. Well, I think I'm about to be proved wrong. It was definitely not going to be -1. Minus k. Wait, no, maybe it is. So -k is, if I add 5/2, I get 2/2, which is 1. Ooh, yeah, I thought at the last second there that wasn't going to happen, but it did. So I think my values of k are 1 and -1. All right, that's a good problem. Let's take a look at the next one. The next one seems to be indicating that we're going to use a calculator, but let's see what we should do in terms of work to begin with. So we want the equation of the line tangent to y equals the natural log of the square root of x plus 3x to the 2/5 at x equals 3, and we want that in slope-intercept form. So, yeah, no, this is like almost entirely calculator, because I don't, like, what am I going to do? I'm allowed to use a calculator, so I'm not going to find the derivative by hand, but you could find the derivative by hand. I always find that tempting, but you should definitely learn, especially if you're in like AP calculus, if you're allowed a calculator, use your calculator for what it's allowed to do. So I need to find y such that x equals 3, and I need dy dx or y prime such that x equals 3. And then, all right, I'm going to use a calculator, and then I will write the answer in. So let's go back to the calculator. All right, so I'm going to store this thing as a new f of x. It's going to be the natural log of x to the 1/2. Because again, I don't like using those templates. It's on the, if I'm using the handheld, it's more convenient, but when you're just doing it on the computer, it's kind of annoying. So I need to know what f of 3 is, and I need to know what the derivative is. I'm going to use derivative at a point. Menu, what am I pressing here? What did I press that made that? Oh, I bet I hit control menu. Menu, calculus, derivative at a point. X is my variable, 3 is the point, and then I want f of x, so I'll just press the var key here. F of x, and then control enter. Okay, so I'm going to handwrite those for a second. Give me a second here. 5.205 and 0.787. Now we want this in slope-intercept form instead of point-slope form, which would be my preferred way. So I'm going to use a calculator to do that. So it's just going to be y is equal to the slope, and then x minus 3, and then plus the y value that we found. All right, I'm going to press enter, see what this gives me. So I'm going to say, I'm going to write that down. So y is approximately 0.787x plus 2.843. It's really weird to be asked for it in slope-intercept form, in my opinion. But I think that's what we need to do. All right, let's go back. So this one's also a calculator question. We want, let f be a function with f of -3 is 2. F prime is the square root of x to the 5th over x squared plus 3. What is the tangent line approximation of f of -2.4? All right. So, I mean, on a calculator thing, I would probably just do this on my calculator, get an answer, and like move on if it was multiple choice or a short answer. But if I have to show work, I need to, you know, kind of do stuff. So my tangent line is going to be y minus f of -3 equals f prime of -3, and then x plus 3. -2.4 is really far from -3 as far as tangent lines are concerned, but like That's the problem, so we don't need to worry about it. So then we would say that f of negative 2.4 is approximately f of negative 3 plus f prime of negative 3 times negative 2.4 plus 3. All right. I'm going to get a calculator. Just tell me the answer. So f of negative 2.4 is approximately... Back to the calculator. Let's see what we get here. All right. So I'm going to start a new document. I always name my derivatives df. So I'm going to say df of x is the fifth. So I need the square. I'm going to use square root x to the fifth. You should use the square root template for that. And then x squared plus 3. Okay, so, and then, all right, so I'm doing 2 plus df, the derivative at negative 3, and then negative 2.4 plus 3. Plus 3? Yeah, plus 3, because it's at negative 3. All right, I'm going to press enter. Error, what? Why? Oh, bad question. I didn't check this before I did it. You know what? Let's modify the question right now on the fly. I'll go back and change it as we do it. So the problem is negative 3 is not in the domain of that derivative, right? Because I'm doing a square root of a negative when I do to the fifth. So let's just change it to f of 3. I'm going to change it on the... When I go back, I'll also change it. I'm going to make it... We're going to approximate f of 2.4 using the tangent line at x equals 3. Everything else will be the same. So I'm going to get this. When I go back, I will erase stuff so that you can see what I've changed this problem to. But this is what I'm talking about. I'm doing these on the fly. I did not try them ahead of time. So, well, I wrote them. And as I write a problem, I always try to think, like, is this going to work? But obviously it doesn't always work. So let's go back. Okay, so here's the deal. We are changing the problem. And first up, I'm going to erase that. I'm erasing that also. And that. That is going to be the correct answer to the problem. I need to erase this. Great. This is the way to do it. Okay, so this is going to be positive 2.4, positive 3. Which makes this minus 3, which makes this minus that, which I think makes all of this right. So question 8, sort of a disaster. Will the other ones be a disaster? We can only hope not. There you go. Okay, so that's question 8. Let's keep rolling. Question 9, evaluate. So this has the limit as h approaches 0. As soon as I see that, I think this is probably the definition of the derivative. Right? And the definition of the derivative is the limit as h approaches 0, f of x plus h minus f of x over h should be f prime of x. So in this problem, I think that f of x is x to the 1/3, and I think that we've just replaced every x with a 3. So I need to find the derivative, so I'm looking for f prime of 3. So f prime of x is 1/3 x to the negative 2/3. So f prime of 3 is not really pretty. It's 1/3 3 to the negative 2/3, which I guess, I mean, you can simplify that a little bit to like 1/3 times 3 to the 2/3. So I think if this was a multiple choice, you might actually have to choose 3 to the 5/3 because you add the exponents there. I think that's the answer. I'm going to stick with that. We could check it on the calculator, but like, you know, let's live dangerously. All right, number 10. This is the last one I'm going to do in this like shot, and then I'm going to be back to do more. I don't know. It won't impact the video, so I don't know why I'm telling you that. All right, we want to evaluate this. This looks to me like the exact same problem. So I like debated with myself, should I like sort them or should I just do them? I decided to just do them. So, you know, you're going to get some questions that are similar kind of in a row. Limit as h approaches 0. So I think in this case, f of x is, what do I think f of x is? Oh, I think f of x is 5 to the x. And so then I'm doing f prime of 2. So I think that because it would be, f of x plus h minus f of x over h, limit as h approaches 0. And then that would have become the limit as h approaches. I'm going to end up writing the exact same thing. Why am I bothering with this? Yeah, this is definitely the derivative at 2. We have plugged in 2. So f prime of x, the derivative of a to the x is a to the u, or a to the u. The derivative of a to the u is a to the u, natural log of a, times the derivative. So times 1, which doesn't really matter, but so f prime of 2 is going to be 5 squared natural log of 5, which I'm going to write as 25 natural log of 5. Okay, we're on number 11, and it looks like we are going to start finding derivatives. So let's go for it. This looks like a product rule with a little bit of chain rule, and then probably got to clean it up. So f prime of x is, we got first, and we got second, and I'm probably not going to change color all that time, but who knows. So first, and then derivative of the second is, so there's a 3 by the power rule and a negative 1, so I'm going to write negative 3. 1 minus x squared plus second, 1 minus x cubed, derivative of the first. So there's a 5 from the power rule and a 2x, so I'm going to say 10x x squared plus 5 to the 4th. Okay, so now we got to factor this thing. So I can take out, because of this, I can take out x squared plus 5 to the 4th. I can take out 1 minus x squared. So that's what's coming out. So x squared plus 5 to the 4th. And then 1 minus x squared. And then we are left with, should I just use a totally different color? There's a negative 3 and an x squared plus 5. So negative 3x squared minus 15. And then in this part, I took out, there's still one of these left, and there's still a 10x. So we're going to multiply those and get plus 10x minus 10x squared. And let's write our final answer in only one color. So we'll have x squared plus 5. This isn't guaranteed to be our our final answer, because I didn't look at it, but sometimes like something will factor out of this like last little factor, and I hate that. Negative 13x squared plus 10x minus 15. Should we check this on a calculator? I think so. I think there's a really good chance the calculator will say that this is x minus 1 squared, because it likes to do nonsense like that. Let's see that. Let's try on the calculator and see if we get the same thing. So I'm going to do derivative. So the shortcut for derivative is shift and then minus x. On the handheld, that's actually like fast. On here, it is not fast. It's faster for me to type derivative, actually, I think. And then 1 minus x cubed. Nope. 1 minus x cubed the whole thing. Press enter. Let's see what we get. So there's a negative. We got the same answer. The calculator just has chosen to do some things. It took a negative out of this. We did not. And then it did make this x minus 1 instead of 1 minus x. Overall, though, good showing by us, I think. All right, next up. If f of x is inverse tangent or arctan, and g of x is e to the 4x squared, what is d dx of f of g of x? All right, so it's going to be f, what am I doing? I'm writing with a laser pointer. F prime of g of x, g prime of x. So f prime of x is the derivative of arctan, which is 1 over 1 plus x squared. And then g prime is going to be e to the 4x squared times the derivative of 4x squared, so times 8x. All right, so this is going to be, I could write it out like this, 1 plus, I have to plug g in, so it's going to be the quantity e to the 4x squared squared, and then times, let's say 8x e to the 4x squared. Now, how would this be simplified? I think it would be 8x e to the 4x squared over 1 plus, when you have a power to a power, you multiply the powers. So I'm going to get e to the 8x squared. I think that's our answer. We could check that on the calculator, but I don't want to. So you could check it, and if I'm wrong, you could feel free to let me know. All right, if f of x is the natural log of x cubed, so it's the cube of the natural log of x, then what is f prime of 4? All right, good stuff. F prime of x is the derivative of something cubed is 3 times that thing squared times the derivative of that thing. The derivative of natural log is 1 over x. So f prime of 4 will be 3 natural log of 4 squared over 4. That's not going to clean up. That looks good. Good enough. All right, next. We want to find f prime for f of x equals the cube root of 1 minus 6x minus 3x squared. All right, so we're finding the derivative of, I'm a big advocate of getting rid of radicals. I like to use rational exponents like every chance I get. We got this, so f prime. The derivative of something to the 1/3 is 1/3 that thing to the negative 2/3, right? Bring it down, subtract 1 times the derivative of that thing. The derivative of 1 minus 6x minus 3x squared is negative 6x. Nope, it's just negative 6 and then minus 6x. It's like, was my brain jumping ahead? I don't think so. I think I was just screwing up. F prime of x is, so I like this. The 1/3 and this can cancel. So I'm going to get negative 2 minus 2x over, let's just bring this down. I'm not going to go back to radicals. If it's multiple choice, you have to go back to radicals, but if not, I don't think it's like super useful. If we did need to go back to radicals though, so I think, I don't know, multiple choice, this might look like negative 2 and then x plus 1. And then here, I think we would have like the cube root of 1 minus 6x minus 3x squared squared. I think it would look like that on multiple choice. I don't really know. If I wrote the multiple choice, I would leave it like this because I don't like radicals. I also don't like typing radicals. All right, let's see what number 15 says. If y is sine of 2x times cosine of 3x, then what is dy dx? I don't think there's anything special about this, so let's just product rule it. Dy dx. So we got a first and we got a second, and I'm going to try to use the colors. So first, derivative of the second. The derivative of cosine is negative sine, and then we get a 3 from the chain rule, negative 3 sine of 3x. And then we have, I always try to change there, but plus the second. And the derivative of the first is going to be, the derivative of sine is cosine, and then you pick up a 2 from the chain rule. So 2 cosine of 2x. All right. What simplifies? Absolutely nothing. So, I mean, I think we should just write our answer, though, in a better way. Dy dx. I'm going to write negative 3 sine 2x sine 3x, and then plus 2 cosine 2x cosine 3x. I don't think the order matters. I just decided to put them in the same order. This like almost feels like you have like cosine minus sine feels like cosine of a plus b, but they don't have the same coefficients. And also in calculus, you don't do that kind of, in AP calculus, you don't do that kind of trig formula stuff all that often. So I'm gonna leave that there. Let's look at this. If x is 2 to the y times 3 to the 2y, find dx dy. So this problem is like exactly the same as any problem you've ever solved. And don't be afraid of that, because I mean, it's basically just this problem, 2 to the x, 3 to the 2x, and find dy dx, right? It's like the exact same problem, just spelled differently. So let's do it. Is there a trick that I can do here? There kind of is, I guess, because I can rewrite this. I'm not sure this is the best idea, but I'm going to do it. So I can rewrite this as 2 to the y. I'm going to make this 3 squared to the y. So that's 2 to the y, 9 to the y. So now they have the same exponent, so we can multiply the bases. 2 times 9 to the y. So x is 18 to the y, which means dx dy is going to be, the derivative of this is going to be 18 to the y natural log of 18 times the derivative of y, where y is the independent variable. So the derivative, like think about it, the derivative of x in almost all contexts is 1 because x is the independent variable. In this case, y is the independent variable, so its derivative is 1. So I think this is the answer. I mean, I know this is the answer. 18y natural log of 18. I don't know, though. I mean, I feel like diving in, I probably would have done this differently. I probably would have done dx dy. I would have jumped right in. Dx dy. So I'm just going to show you. I would have done first, the derivative of the second is 3 to the 2y times natural log of 3 times 2 plus second, which is 3 to the 2y. The derivative of the first of the derivative of 2 to the y is 2 to the y natural log of 2 times 1, but whatever. Now, how do I get from this to, how do I get from this to this? Because one of those seems way nicer than the other. I can take out a 2. So we're going to do 2 to the y, 3 to the 2y. Take that out. This gives me 2 natural log of 3 plus natural log of 2. All right, now we need some properties of stuff. 2 to the y. We're going to do the 3 squared to the y thing again. And then coefficients become exponents. So that'll be natural log of 3 squared is 9 plus natural log of 2. And then this is 2 to the y times 9 to the y is going to be 18 to the y. And then this is when you have natural logs in addition between them, it becomes multiplication. So natural log of 18. So look at that. Same thing. One of them was way easier. If this was multiple choice, I have absolutely no idea what the answer choice would look like. I mean, it should look like this, right? Because we can get there, but there's no telling. Number 17, arc cosine. So you probably have arc sine memorized and arc tan memorized, as you should. Arc cosine and arc cotan are just negative of those derivatives. So it's the same kind of thing that you get with arc sine, with sine and cosine. So the derivative of cosine inverse of x is just negative 1 over the square root of 1 minus x squared. So we got to know that. And once we know that, this is just chain rule problem. So dy dx. So the derivative inverse cosine of something is negative 1 over the square root of 1 minus that thing squared. So e to the 5x squared times the derivative of e to the 5x, which is 5e to the 5x. All right, now this is a killer 5, by the way. Now I'm going to simplify this a little. So I'm going to say it's 5e to the 5x, well, negative, over the square root of 1 minus e to the 10x. There we go. That's dy dx. All right. Number 18 here. Not a calculator problem, but I might want it to be a calculator problem. If f of x is x squared minus k over x squared plus 2k with k not equal to 0, and f prime of 1 is -6, then what is the value of k? All right, we got to find f prime, plug in 1, set it equal to -6, and then solve. That's the only way this is going to work. So here goes. This is a quotient rule problem. F prime of x. Bottom. Derivative of the top is 2x. Minus top. So like this is gross, but I'm just going to plug in 1. So I'm not worried about like simplifying it. So bottom derivative of top minus top derivative of the bottom is 2x. Remember, k is a constant. So every time you take the derivative of k, you just get 0. So the derivative of 2k is 0. So that's why we're just getting this. All over x squared plus 2k squared. So far, so good. Now we're going to use this. So -6. I'm hoping that I chose -6 because it like makes this math work out nicely. But I don't know about that. X is 1. So I get 1 plus 2k times 2 minus 1 minus k times 2. It's looking kind of linear, so that would be good. Well, now it's not. 1 plus 2k squared. Ugh. All right. So -6, 1 plus 2k squared is 2 plus 4k minus 2 plus 2k. Okay, let's keep going. So we get -6. I'm running out of room. 1 plus multiplying together times 2, square it. On this side, we just get 6k. You divide everything by -6, I guess, at this point, and you'll have 4k squared plus 4k plus 1 is -k. Is this going to factor? I don't think so. So, I mean, like, this was nice until here, and now I'm, like, getting a gross answer. Was this supposed to have a calculator by it? Maybe. I get 4k squared plus 5k plus 1 equals 0. I'm going to try this again on the calculator just in case. Oh wait, does this factor? If I do 4k, k, yeah, 1 and 1. Okay, I thought that did not factor. So I'm getting k is -1/4, or k is -1. Does something about either of these make this problem not work? So k is not allowed to be 0, but I don't know. I think it works. All right, I'm gonna switch to the calculator and try this out. So let's see. Go to a calculator. All right, f of x is x squared minus k. When I type on the calculator, I'm using the internal mic, I think, on my MacBook. Well, I know I'm using the internal mic. It really picks up the typing, and it sounds horrible, and I wish it wasn't the case, but there's nothing I can do. All right, so I'm going to do it all in one shot. Menu 3, 1. We're going to solve the derivative. So shift and this with respect to x of f of x equals -6. We want to solve for k such that, which I could have just typed, but I didn't, x equals 1. Let's see what we get. -1 and -1/4, which is exactly what we got. So I think we did it right. All right, let's take a look at number 19 now. We got f and g are differentiable functions such that this table, I guess, is true. And if h of x is f of g of x, we want to find h prime of 3. All right, so we can do that, I think. So first, h prime of x. This is a chain rule, so it's going to be f prime of g of x g prime of x. So h prime of 3 will be f prime of g of 3. Now we get to find out if I made this table right. 3. All right, so that's going to be f prime of g of 3 is 5. So f prime of 5, g prime of 3, f prime of 5 is 2, and g prime of 3 is 7. I believe the answer is 14. That one wasn't bad. That was pretty straightforward. All right. Similar question. Let f be a differentiable function on the interval from 1 to 3.5, and g of x equal f of x. Use the table of values to approximate g prime of 2. Okay, so g prime of x is going to be f prime of x times f prime of x, the chain rule. So g prime of 2 is f prime f of 2, f prime of 2. F of 2 is 1.5. Yes. Okay, so g prime of 2 is going to be f prime of 1.5 times f prime of 2. All right, now we're trying to approximate this thing. So we got to approximate f prime of 1.5 and f prime of 2. So to do that, so for 1.5, I'm going to go to the left and the right and say f prime of 1.5 is approximately f of 2 minus f of 1 over 2 minus 1, which will be 1.5 minus 1.8 over 1, so negative 0.3. And then we got to do the same thing for f prime of 2. So 2 is in between 1.5 and 2.5. So I'm going to do f of 2.5 minus f of 1.5 over 1, because that's 2.5 minus 1.5. So that'll be 1.9. What am I doing? Yeah, 1.9 minus 2.2 over 1, which is another negative 0.3. Okay, so then we'll say that g prime of 2 is approximately negative, I'm going to go with 3/10 times negative 3/10, because I secretly hate multiplying decimals. 9 over 100.09. There we go. That was a good question. So we had to do a chain rule thing and then approximate some derivatives. I like it. Let's take a look at number 21. 21 seems to be very related. All right, because as I mentioned, I considered sorting them and then I didn't. Actually, they were like I wrote them in a random order and then I went back and sorted them so that they actually are all together. So maybe that was a mistake, but what are you going to do? All right, so differentiable function, g of x is this. We want g prime. So g prime of x is a chain rule problem. It's going to be f prime x over 2 times the derivative of x over 2. So then g prime of 4.6 is f prime of 4.6 over 2 is 2.3 times 1/2. All right, now what do I need to do? 2.3. I need to approximate 2.3 is in between 2.2 and 2.4. So f prime, I don't know why I'm doing this off to the side, but I am. So it'll be f of 2.4, which is 6.4. F of 2.2 is 5.5 over 2.4 minus 2.2, which is 0.2. Okay, so this is, no, it's 0.9 over 0.2. I think that's right, which is 9 over 2. So I'm going to say that g prime of 4.6 is approximately 9 over 2 times 1/2, which is 9/4. This whole thing feels very decimal, so I'm going to say 2.25. Okay, so a thing that's really important is like, woo, the heck, is this approximately equal to sign. So we need that. Like, it's not actually that. We're only approximating it. We can't actually find the exact value in this particular problem. All right, new problem. And it's our little dolphin friend. So this is a calculator problem. So a particle moves along the x-axis at a time t greater than 0. Its position is given by x of t equals t to the fourth minus 3t cubed minus 5t squared. At the instant that the particle's acceleration is 0, what is the particle's velocity? Okay, so acceleration is the second derivative of position. And we need that to equal 0. So I'm going to use a calculator to get that. And then I'm going to find v of that. So velocity, let's say v of t is x prime of t. So you want to get in the habit of doing that, because on the free response, to get the full credit, you need to link position to velocity, and like velocity to acceleration, or acceleration to position. Like, you have to like link them. So that's why I'm doing that. But anyway, I'm going to switch over to the calculator because it's going to do the whole problem for me. So let's see. All right, so I'm going to define x of t, which is I think, kind of a bad idea. The cursor is universally in my way when I'm typing on this calculator. I think it's a bad idea because then when I try to use x again later at some point, it'll be defined. And you don't really want that for most things, but whatever. T to the fourth minus 3t cubed minus 5t squared. Okay, so we're going to solve. I want the derivative. So I'm going to do, what am I going to do? Template, second derivative, t, x of t equals 0, and I want to solve that for t. So I get a negative value and a positive value, but I only want the positive value because t has to be greater than 0. So I'm gonna write that down. Maybe you will too. 1.931. And then what am I doing? I'm doing the velocity at that value. So I need to do the derivative at a point, right? So I'm gonna do menu for derivative at a point. What the? Oh, see, I think this is the problem. Right? So t, wow, that's weird. It gave me the variable and then filled in. The variable should be t, and then the thing that I want is going to be like 1 point. I'm just going to put 1 for now, and I'm going to change that. So I want to find the derivative of, man, that was like instant karma. I said that I shouldn't really define x, and then as soon as I tried to use it, it got weird. I'm going to delete this and just go up here and copy this. And paste it. I get negative 24.068. So v of 1.931 approximately negative 24.068. Let's go back to the iPad and see what this looks like. All right, so I've written all that down. Okay. Let's take a look at the next one. This does not have a calculator thing next to it, so I guess we're doing it by hand. Particle is moving along the x-axis with position given by x of t is t over t plus 4 from 1 to 3. For what values of t does the particle's instantaneous velocity equal its average velocity on the interval? So this is kind of the mean value theorem, which is sorely lacking in this midterm review that we're doing. But it doesn't really matter if the mean value theorem applies on this because we're just being told to like try to solve this. So I need to find instantaneous velocity and I need average velocity. So instantaneous is the derivative, right? V of t is x prime of t, which will be bottom, derivative of the top, minus top, derivative of the bottom, all over the bottom squared. And this simplifies to something. We got t plus 4 minus t, so just 4 over t plus 4 squared. All right, we also need the average velocity, which is going to be change in position over time. So it's going to be x of 3 minus x of 1 over 3 minus 1, which is x of 3 is 3 over 7. X of 1 is 1 over 5 over 2. All right, so we got 15 minus 7 over, I'm going to say 2 times 35. It's like over 35, but then over 2, so we can just simplify that. So that gives me 8 over 35, or 8 over 35 times 2, so just 4 over 35. All right, we got to set these equal. So I have 4 over t plus 4 squared, 4 over 35. So I mean, definitely t plus 4 squared is 35. So that means that t plus 4 is either plus or minus root 35. I'm not honestly sure that either of these answers is on this interval. I mean, I guess it must be, because the mean value theorem applies, and I'm applying it. So I'm going to say that t is -4 plus or minus root 35. So if we think about it, we've got to be between 1 and 3. And so -4 minus something, there's no chance that it's in there. So I'm going to say t is -4 plus radical 35. And it must be on the interval, because there's guaranteed to be a value on the interval by the mean value theorem. We found 2 potential things, and one of them is definitely not. So this is our answer, I'm pretty sure. Let's look at the next one. We're given that f of x above, no, we're given f of x above, find a and b such that f is continuous at x equals 1. All right, so continuous, so if this was multiple choice, like we would just dive in. We need the limit as x approaches 1 from the left to equal the limit as x approaches 1 from the right to equal f of 1, right? That's a 3-part definition of continuity. The limit exists, the function exists, the limit equals the value of the function. For the limit to exist, the limit from the left equals the limit from the right. So we need these 3 things. One of them is going to be, like, one of these 2 is definitely equal to this because of the equality. So when x is greater than or equal to 1, we're supposed to use this branch, which means the limit from the right, these 2 are equal, like by themselves. So we don't really need to worry about that. So for this first limit, we just use this branch, right? Because we're less than 1, so that's just a. That's going to have to equal, we're going to use this branch. That's b plus, it's b plus 1 plus 1, so b plus 2. Find a and b. So that find a and b, I just got a is equal to b plus 2 at 1. So as long as a is equal to b plus 2, is that true? I think that's true. I don't think we can find a and b. I think we can just find a relationship between a and b. I wonder if it was supposed to be differentiable. Would differentiable work? You know what, let's just leave it as this. We'll find a relationship between a and b. And let's go to the calculator and like plug in some values, right? So like a needs to equal b plus 2. So I'm gonna go back to the calculator, and I'm gonna define a piecewise function. Ready? F of x. I'm gonna delete the variable x because it's just messing things up. F of x is piecewise function. So it's gonna be a times x. X is less than 1. So this is, we're suffering right now because I think I wrote a bad problem. It's not really the calculus that's getting us. And then x is greater than or equal to 1. All right, so I'm going to graph this thing, and I'm going to try out a couple of values where a is equal to b plus 2. This is what I would do if I were like taking an exam and I got some weird thing such that a is equal to b plus 2. So I'm going to say like a is, I don't know, 4, and then b would have to be 2 because it's b plus 2. I do not want to create a slider, so cancel that. And yeah, that looks continuous. A is equal to b plus 2, so if b is 5, then a would have to be 7. And I don't want to create a slider. It still looks good. Let's try negative. -1, then a is equal to b plus 2, so 1. Do not want to create a slider. Yeah, so that's the relationship. There's not enough information to actually do the problem that was given. So apologies, but also, I don't know, maybe we learned something, but I don't think so. We got to play around on the calculator. Next up, uh, given that f of x is the function shown above, find the value of a plus b so that the function f of x is differentiable everywhere. All right, so this is like similar, and maybe this is the actual problem that we should have had last time. So continuous, so we're going to operate on like two different levels here, right? The first one is we need to make this thing continuous, which means we're going to do the limit from the left and the limit from the right. I'm not going to show great work on this because it takes a really long time to do great work. But basically what we're trying to show is the limit as x approaches 2 from the left of f of x has to equal the limit as x approaches 2 from the right of f of x. We need this to be true. So from the left, we're going to get x is 2. So you get 4 minus 4b plus 1, right? Because from the left, we would use this. And then from the right, we're going to use this. So it's going to be 8a minus 6b plus 4. Okay, so far, whatever. What am I doing here? I guess I'll bring, so you basically get 1 is equal to 8a minus 2b from that. So that's a relationship. Now we want differentiable, which means I'm going to find the derivative of each branch, which it's kind of, so there's nothing fancy about this. These are both just power rule situations. So 4ax minus 3b, that's going to be when x is greater than 2. You drop the equals because we don't like know if it's differentiable. And then 2x minus 2b when x is less than 2. I'm going to do the same thing here. I'm just going to plug 2 into both of these branches, rather both of these branches, and set them equal. So that'll be 8a minus 3b equals 4 minus 2b. I have to solve a system. 8a minus b is 4. I mean, maybe this isn't the hardest system in the world because we have 8a minus 2b is 1, and we have 8a minus b is 4. Let's subtract and find b. So we'll get negative b is negative 3. B is 3. And if b is 3, then 8a minus 3 is 4. So a is 7/8. This is annoying because then we got to find a plus b. So a plus b is 3 plus 7/8, which is 24/31 over 8. Should we check that on a calculator? Maybe. And if I get it wrong, I'm going to leave it in and I'm going to correct it. That's my game plan. So let's see. I'm going to do kind of the same thing here. I'm going to create, actually, so I could create a piecewise function, but I think what I'm going to do is I'm just going to like create an f1 and an f2. So f1 will be 2a times x squared minus 3b times x. You have to put the multiplication or the calculator will think the variable is like bx, which you don't want, and then f2 of x. Look at that cursor just sitting right in our way, always. X squared minus 2b times x plus 1. All right, so what I want to do is I'm going to solve a system of equations. Menu 3, 7, system of equations. 2 equations, 2 unknowns. The unknowns are actually going to be a and b. All right, and first up, we got f1 of 2 should equal f2 of 2. And then the next one is the derivative. So we want the derivative with respect to x of f1 of x such that x is 2. I guess. I'm not sure if this is going to work. This seems weird. I'm going to do this. I'm going to try to put such that at like the very end. Hopefully it works. 2 of x. And then out here I'm going to say such that x equals 1, 2. I don't know. Yeah, 3 and 7/8. Nice. Is 3 plus 7/8 what I think it is? 31/8. I think it is. All right. That worked out better than I thought it would. So let's go back. All right, which of the following is not differentiable at x equals 3/4? All right, so this one, what color are we using? This one, the domain is x is greater than or equal to 2. So 3/4 is not in the domain, and if you're not in the domain, you're not continuous, so you're not differentiable. I kind of object to that being an option, uh, but I mean, I think it's not differentiable there since it doesn't exist there. So I'll count it, I guess. This one has a the vertex is 3/4 0, and we know that it kind of goes like definitely not differentiable there. So far we've got this and this, which means the answer is either D or E at this point. And then this one, let's actually find the derivative. So it'll be 1/3 this thing to the negative 2/3 and then times 4. So what's key about that is that we're getting 4 over 3, 4x minus 3 to the 2/3. Since this is in the denominator, if we try to plug in 3/4, we're dividing by 0, which we cannot do, so this also works. So I think the answer is E. I would prefer that the answer be t of x and f of x, but that's not an option. Like, we had to choose the best available option, so you kind of have to include g of x, even though I just object to that idea. If it's not that it's like a point, like a, a one, like a jump or a vertical discontinuity. It's like not in the domain. It's like, I don't agree, but whatever. Number 27, suppose a function is defined so that the limit as x approaches 5 of f of x is negative 3. Which of the following must be true? F prime 5 exists. Why would that have to be true, right? I mean, you could, let's do something here. There you go. That limit exists, but the function doesn't exist. Actually, this is a really good graph. The derivative does not exist for this graph. Let's assume that this is at 5 and then whatever, negative 3, right? So f prime doesn't exist. We're not continuous. It's not defined. I didn't even make f of 5 equal anything. The answer has to be none of the above. One good graph can answer a lot of questions. So what you want to do, though, is try to like get as few assumptions into your graph as possible. So the problem didn't say the function was differentiable. It didn't say the function was continuous. So try to draw something that satisfies it that is not continuous or differentiable, because it might unlock answering the question. All right, let's look at the next one. Implicit looks like. So find dy dx for this thing. So we're going to go with d dx, 2x, d dx, 3 sine of y minus 2y. Okay, so the derivative of 2x with respect to x is 2. The derivative of 3 sine of something is 3 cosine of that thing. And then the derivative of y with respect to x is dy dx. And then the derivative of negative 2 times something is negative 2 times the derivative of that thing. The derivative is dy dx. All right, so then our answer, you can factor dy dx out of both things on the right-hand side and just get 2 over 3 cosine of y minus 2. I think that's the answer. All right, let's move on. That was a good one. Given that 4x squared minus 3xy plus 2y squared equals 9, then what is the value of dy dx when y is equal to 1? All right, so we have to do a calculus problem and an algebra problem. Which do we want to do first? I kind of want to do the calculus first, but like we're going to need the algebra. So when y is equal to 1, I'm going to figure out what x is. So 4x squared minus 3x times 1 plus 2 times 1 squared is 2 is 9. So what? 4x squared minus 3x minus 7 is 0. Does this factor? Or is this a mistake? Let's do b squared minus 4ac and see if that's a perfect square. That's 9 plus 4, 16 times 7. This is more math than I was planning to do. 2 carry the 4, 1, 1, 2, 121. Factors. Okay. So then if there's more than one, how am I finding dy dx? I don't know. Let's say 2x. So why didn't I just continue using the quadratic formula? I don't know. 2x and 2x, 7 and 1, that's wrong. So let's go back to 4x. Why didn't I just use the quadratic formula? 4x and x. I want to do minus 7 plus 1. So x is 7/4 and x is -1. Is there some restriction here? There's not. So do I have to find two different values? Maybe. All right, let me move this off to the side because I think I'm gonna need a lot of room. So d dx of all this. This one, I'm gonna put this on the check on calculator list because who knows, maybe I did it wrong. D dx of 9. All right, so 8x. So what I like to do here is I consider like this the first function, and then I consider this the second function. So I'm going to do first derivative of the second plus second derivative of the first. And then this will be 2y squared gives me 4y dy dx. Then the biggest mistake I see people make is they forget that the derivative of a constant is 0. So this is 0. All right, so dy dx is, so do I want to, I mean, I guess, ordinarily what I would do is not solve this, and I would instead just plug in values at this point and solve for dy dx, but I don't want to plug in 7/4 no matter what happens. So I'm kind of being lazy maybe and hoping something weird happens here. So I'm moving basically everything that doesn't have a dy dx from that side over to this side. So this doesn't have a dy dx, so it comes over as positive. This doesn't, so it's going to come over as negative. And those are the only things without a dy dx. Now, the coefficient of dy dx is 4y minus 3x. So 4y minus 3x. All right. There's no way around this, I guess. I'm going to have to plug in negative. I feel like it was supposed to be -1, 1, but I don't know. So dy dx at -1, 1 is going to be 3 minus 8 times -1 is plus 8 over 4 plus 3. So 11 over 7. Let's try the next one. And then I'm definitely checking this on the calculator because this number is not pleasant. Oops, nope. 7/4 and 1 because y is 1, right? So this will give me 3. So I have 8 over 4 is 2 times 7 is 14. And then if x, so I get 4 minus, oh man, 21/4. This can't be what I meant. I mean, it could be, but why did I do this? -11, 16 minus 21 is -5/4. So I'm getting 44 over 5. These are the two answers that I've gotten. I don't know. Let's take a look on the calculator. I mean, this is not a calculator problem, but well, I don't know. Who's making the rules, right? So menu, option 4 for calculus, press up a couple times, get to implicit differentiation. And then we're going to type it in. So 4x squared minus 3x times y, and then plus 2y squared is 9, comma x, comma y. Okay. Now let's do a little solve here and see what it tells us our values are. Let's solve. I'm just going to copy and paste this down. This thing for x when y is equal to 1. Yeah, it gives the values. All right, so then might as well finish checking. X is -1 and y is 1. And then also x is 7/4 and y is 1. Excellent, I guess. We got it right. Good stuff. I'm going to do two more of these and then take a break, which of course does not impact you, so I don't know why I keep telling you that. I mean, I guess it could potentially impact you. I don't know how, but somehow. So we got these 11 over 7, 44 over 5. Good job, us. Kind of surprising. Write the equation line tangent to the curve at the point where y equals 1. Now, what in the world is happening here? My guess, oh no. I mean, like, this could have been a plus. That seems like the most likely thing because shift equals is plus. But I mean, this could be a plus or this could be a plus, but I don't know why. I'm going to say this is the plus. Does it make a difference? It does, unfortunately. Let's assume that this one is a plus and see what happens. So if y is equal to 1, we would get 1 plus 2x cubed is negative 15. 2x cubed, negative 16, x cubed is negative 8, so x is negative 2. We're going with that. We're going to say that that was supposed to be a plus there. Because otherwise, is it worse? Is it exactly the same? It can't be exactly the same, right? Because that would be like plus, minus, I don't know. It would like change it from a plus to a minus. We're doing this. We're doing this one. It's a plus. All right, so our ordered pair is going to be negative 2, 1. Now we got to find a derivative. So we are doing d dx of y to the 5th plus 2x cubed y is d dx of negative 15. All right, so 5y to the 4th dy dx plus, we're doing the thing, right, where we treat this as the first function and then y as the second. So it's going to be first derivative of y is dy dx. Second is y. Derivative of the first is 6x squared. And then that should equal 0. I need to find dy dx, right? And I know the ordered pair is negative 2, 1. So I'm going to do the thing. I'm just going to sub in at this point and say, if y is equal to 1, this will be 5 dy dx. This is a little easier sometimes than actually like solving for dy dx and then subbing in. Because algebra is just harder than arithmetic, basically, is why. So if x is negative 2, this will be 2 times negative 8, so negative 16 dy dx. And then, so we got 1 times 6 times 4 is 24. So dy dx is going to be negative 24 over negative 11. So 24 over 11. Okay, and then we want the tangent line. So tangent line y minus 1 is our slope, which is a little crazy. And then x minus negative 2, which is plus 2. Not bad. We did it. I don't know. Didn't love it. Had a typo there. Not a big fan. All right, find dy dx. This is the same deal. I'm going to do a thing because this natural log of a product looks like something I don't want to deal with. So I'm going to rewrite this first. 2x minus 3y. If we have multiplication within, it's going to be addition between. So we can make this natural log of x, natural log of y equals 4. Now I'm going to find the derivative with respect to x of both sides. All right, d dx of 4. So we get 2 minus 3 dy dx. Derivative of natural log of x is 1 over x. The derivative of natural log of y is going to be 1 over y, and then dy dx. And then the derivative of 4 is 0. What are we trying to find here? dy dx. We got to solve for dy dx. How much do we need to simplify it, though, is kind of the real question. So I'm gonna do the thing where I move everything that doesn't have a dy dx from this side to this side. So that means I'm going to subtract 2, and I'm going to subtract 1 over x. So we'll have minus 2 minus 1 over x. And then I'm going to divide, so we're getting dy dx. I'm going to divide by everything here that's a coefficient. So that's negative 3 and 1 over y. So divided by negative 3 plus 1 over y. I mean, would you simplify this? Like, would anyone simplify this? I don't know. Probably. You don't see a lot of answer choices that have complex fractions in them, so I'm thinking. So this would give me negative 2x minus 1 all over x. So I'm going to put the x down here. And then this would be negative 3y plus 1 all over y, but I'm going to take that and put it up here. I don't think there's any chance that that's what the answer would look like. I think the y would be in the front, and I think they'd probably take out the negative. I think that the answer would put, I don't know. I think that the answer would look like, I'm thinking you would factor the negative out of here, and probably the negative out of here, and cancel them. And then, so that would be a negative out of here, a negative out of here. That makes it positive. I think that the answer choice would look like y 2x plus 1 over x 3y minus 1. I think that's what the answer choice would look like. Basically just multiply the top and the bottom by negative 1 and then move the y. That's what I've done effectively. All right, I said I was going to take a break here. Am I though? I'm going to do this next one and then take a break because it looks like the problems really shift there. So this one says, oh, I can change this. What color's best? Oh, that's brighter. All right, let's do that. Let f of x be this. We want to find the value of the derivative of the inverse at x equals 2. Okay, so this is an x value for the inverse. So it's a y value for f. I always think that. So that means that I need to really figure out the x value for f. So this equals 2. So I would say by and large on these problems, you either will have a calculator or you can just guess the value. So here, I mean, if you look at it, x is 1. That definitely works. So I'm going to go with x equals 1. So my ordered pair on f of x looks like 1, 2. And my ordered pair on f inverse of x will look like 2, 1. And the key is that the derivative of, this is so clunky. Let me just name this as g of x. I'm going to say this is g of x. It's all crammed in. No, not looking good. Hold on. There we go. Okay, I'm going to rename this as g of x. So g prime of 2 is going to be 1 over f prime of 1. So if I can find f prime of 1, f prime of x is 5x to the 4th plus 1. F prime of 1 is 5 plus 1, so 6. So then this will be 1 over 6. That is our answer to this question. All right, we are on number 33, and we are doing, it looks like related rates. We got a 10-foot ladder leaning against a vertical wall. I'm going to draw that, or try to. Okay, nice and neat. If the, it's 10 feet, right? So that's never going to change, so I'm going to just put that in. 10-foot ladder. If the bottom of the ladder is pulled along the ground, so let's call this x, away from the wall at a constant rate of 1 foot per second. So that means that over time, x will get bigger. So I'm going to say that dx dt is 1 foot per second. So if it was getting shorter, it'd be -1, but it's going to get longer. How fast will the top of the ladder be moving down the wall when the ladder, so that's, let's call it y, when the ladder is 6 feet from the wall. So we're trying to find dy dt when x is 6. All right, well, the first thing I notice is if x is 6 and this is 10, then this will be 8 at that time. So y will equal 8. And then Pythagorean theorem relates these things, so let's do that. X squared plus y squared is 10 squared. We want to find dy dt, so I'm going to take the derivative of this thing with respect to t. So that's going to be, the derivative of x squared is 2x, and then because x is a function of t, dx dt, plus the derivative of y squared is 2y. Y is a function of time also, so dy dt. That's the chain rule. And then the derivative of a constant is 0. So everything has a 2, so I'm going to cancel them. In fact, you do this calculation a lot, so often that I sometimes skip the part where you write the 2. Dy dt is 0. And then I'm going to sub stuff in, right? So I know that x is 6, y is 8, and dx dt is 1. So it's going to be 6 times 1 plus 8 dy dt is 0. So that means that dy dt is negative 6 over 8, but let's say negative 3/4. And then it'll be the same units as dx dt, so feet per second. Now the question was like, how fast? And that's really a question of speed. So I think that the answer would probably be like moving down at 3/4 feet per second. I don't know. So I'll write that. Moving at 3/4 feet per second. And there we go. Okay, let's take a look at the next question. Oil spilled from a ruptured tanker spreads in a circle whose radius increases at a rate of 3 feet per second. How rapidly is the area enclosed by the ripple increasing at the end of 10 seconds? All right, so we've got a circle and we are told the radius increases. So we know dr dt. Dr dt is going to be 3 feet per second. Since we're dealing with a circle, I'm going to try to draw one. Actually, I'm going to let this become a circle. Boom. It has a radius. And the radius is growing, right? So we're talking about the area. So area is pi r squared. We want the derivative with respect to time because we're looking for the rate of change of the area. So that's going to be dA dt is, pi is a constant. The derivative of r squared is going to be 2r and then dr dt. So we're going to get 2 pi r dr dt. All right, so I know that dr dt is 3. What I don't actually explicitly know is r, but I know that if we go 3 feet per second for 10 seconds, we would then know that r is 30, right? So r will be 3 feet per second times 10 seconds is 30, and that's in feet, not that it really matters. Okay, so dA dt, let's just plug in. dA dt is going to be 2 pi times, well, I guess technically times 30, and then times 3, so that's 90 times 2 is 180 pi. And then we're talking about the rate of change of area, and our units are feet and seconds, so area will be feet squared per second. There we go, not bad. Let's take a look at this next question. A tank filled with water is in the shape of an inverted cone. So inverted cones are like ice cream cones. Like that, I guess. 20 feet high, so this will be 20. With the circular base on top, whose radius is 5. So this will be 5. Water is running out of the bottom of the tank at a constant rate of 2 cubic feet per minute. So that's the rate of change of volume. So dV dt. And it's running out. So we'll say negative 2 feet cubed per minute. Okay, now the question is, how fast is the water level falling when the water is 8 feet deep? How fast is the water falling when the water is 8 feet deep? Okay, so we're looking for like dH dt kind of, I guess. I'm gonna name the variable h. dH dt when h is 8. All right, so I'm gonna take this picture that I have and I'm just gonna draw half of a cross section. So So I'm going to draw this, and this is the overall height, which is 20. This is the overall radius, which is 5. Now for this, I'm going to add in like a little cone that is basically the water level. So this I will call R, and then this height I'm going to call H. These are similar triangles, which means that R over H is 5 over 20, which is 1/4. The question is 100% about H, right? We know what H is. We want dH dt. I need to get rid of R, so I'm going to say that R is 1/4 of H. All right, now what to do with this? We're talking about volume of a cone. I know the volume of a cone is 1/3 pi r squared H. But remember, our goal is to get rid of R because we're being asked everything about H, and we know that R is H over 4. So I'm going to sub that in. So V is, let's say, pi over 3. We got H over 4 squared times H. So our volume is pi over 3 and then H squared over 16. So I'm going to write pi over 48. And then H squared times H is H cubed. All right, so now we have this, and we're just going to find the derivative of this with respect to time, right? Because if I could zoom out to a normal size, we have, we know dv dt, we know we want dh dt, and we know h is equal to 8. So this is going to be derivative with respect to t. So dv dt, pi over 48. Then we're going to get 3h squared dh dt. So 3 over 48 is 1 over 16. So I'm going to do pi over 16, because that's really 3 pi over 48. And then h squared, and then by the chain rule, we get a dh dt. And now it's just sub in and solve, right? So we know that h is 8 and dv dt is -2. So -2 is pi over 16, 8 squared dh dt. And so 8 squared is 64. 64 over 16 is 4. So really, -2 is 4 pi dh dt. And then finally, I'm going to write it over here, I guess. dh dt is -1 over 2 pi. And then the units for this should be the same as the units for, I don't know. Well, the volume is in feet cubed per minute, so this will be feet per minute. So let's, struggling. Feet per minute. There we go. This is the answer that we are looking for, grossly highlighted. Okay, let's do another one. We want to evaluate the limit as x approaches infinity of 2x minus 3 cubed quantity 3x minus 2 squared. So I look at that and I think overall the numerator is to the 5th degree. And then in the denominator I have 1 minus 3x squared, 3x plus 2, and 2x minus 5. That's only the 4th degree, so this is a 5th degree polynomial over a 4th degree polynomial. As we go to infinity, this answer is going to be infinity. I think I messed up. I don't think I wanted this to be the question. I think what I wanted to be the question was probably, I'm gonna write a different question related, and then maybe I'll see if I can turn it into math. I sort of have the ability to do that, but it doesn't always work. So okay, here goes. I want the limit as x approaches infinity of. I think I wanted the question to look like this. Let's do this. X minus 2 squared. I'm going to raise the degree or the multiplicity of one of these things in the denominator here. And maybe I'll make it this one. So we'll make this, no, let's leave this. And then 3x plus 2, let's make this squared. 2x minus 5. Okay, so this is probably what I really wanted. Let's see if I can convert this to math. Let's see how it does. Convert to math. It worked pretty well, except my 2, can I undo that? I can edit it? I don't know what that means. Undo that. Let me change my 2. There's, in the middle of like a probably 3-hour video, you do not need to watch this. But I'm doing it anyway. How come it got the 1, 2, but not the other? All right, convert to math. That looks pretty good. Okay, this I think is what I really wanted to do. So at this point, if you look at it, you have a 5th degree thing and a 5th degree thing. So now it's relevant. Let's look at just the numerator here. So in the numerator, I'm basically going to end up with, just think about dominant terms. You're going to get from the first factor there, 2x cubed is dominant. From the second, you get 3x squared is dominant. Then in the denominator, we have negative 3x squared will dominate, another 3x but squared, and then a 2x. All right, so if you have a 5th degree over a 5th degree, you're going to get the ratio of the dominant term, so the highest powered thing, or the leading coefficients. So here in the numerator, we're going to get, there's a 2 cubed and a 3 squared. In the denominator, there's a 3 squared, a 3 squared, and a 2. So I think that overall, we will get 4 over 9. So that's just a different problem. I mean, I think that's probably what I meant to do, but didn't do the first time. So there you go, multiple examples. Also, I kind of realized that maybe I'm not showing the final result clearly enough for everyone to look at. So I think maybe at the very end, I will just scroll through this slowly so that you can watch all of it. That seems like it'll take forever. There's a lot of problems. I don't know, we'll see. All right, another one, evaluate this limit. So I'm looking at this and I'm thinking occasionally subbing in works. So we should try to do that. So you'll have 2 times 2 squared is 8, minus 3 times 2 is 6, minus 2, that's 0. All right, well, and then 12 minus 16 plus 4 is also 0. So we get 0 over 0. All right, if you are aware of the existence of something called L'Hopital's rule, you can use that. If you're not aware of the existence of L'Hopital's rule, you can algebraically do this one. So we just showed by getting 0 in the numerator and denominator that x minus 2 is a factor. So if you're not really sure how to factor this, it gave you a clue. So I know that x minus 2 is a factor, which means to get 2x squared, I need 2x. To get minus 2, I need plus 1. And then the middle will take care of itself. And then I also know x minus 2 should be a factor of the denominator, which means I would need a 3x to get up to 3x squared, and I would need another minus 2 to get a 4 for my constant. So I can cancel those. So this will give me the limit as x approaches 2 of 2x plus 1 over 3x minus 2, which will be, by substitution, 5 over 4. I think that's the value of the limit. If you do know L'Hopital's and you want to use it, and you want to do, I don't know, kind of bad work, I'm going to do the limit as x approaches 2. So the derivative of the top is 4x minus 3. The derivative of the bottom is 6x minus 8. And then if I sub in, I get 8 minus 3 is 5, and then 12 minus 8 is 4. So you can see we get exactly the same answer regardless of which way we choose to do it. I don't know if there are times where they can force you on like the AP exam to use algebra. I think L'Hopital's is pretty much always on the table. But if it's free response, you got to make sure you do good work. I'm going to choose to do good work on this problem. So hopefully just subbing in will give us an answer. But if I plug in, I get e to the 0, which is 1, minus 1. So I get 0 there. And then I get sine of 0, which is 0. So this is 0 over 0. All right, so if I want to do good work on this, I'm going to do L'Hopital's. But I'm going to start off by saying, what happened here? The limit as x approaches 0 of e to the 4x minus 1 is equal to the limit as x approaches 0 of sine of 3x equals 0. All right, so we do them independent of each other. Then we say, therefore, by L'Hopital's, the original limit, the limit as x approaches 0, e to the 4x minus, kind of looks like I'm in an exponent there, of sine of x, 3x, equals, now let's actually use L'Hopital, so it's the derivative of the top and the derivative of the bottom. So it's not the quotient rule. The derivative of e to the 4x is 4e to the 4x. The derivative of sine of 3x is 3 cosine of 3x. So now we try to sub in 0, we get 4e to the 0 over 3 cosine of 0. E to the 0 is 1, cosine of 0 is 1, so this is 4/3. There you go. That's pretty good. All right, let's take a look at the next one. This is a pretty solid review. I mean, there's a lot here. I do think there's like a lot missing. There's a lot of just like straight practice taking derivative problems that are missing. Mean value theorem is completely underrepresented in these problems. And I didn't do a lot with optimization. I think I might come back and do an entirely different video on optimization problems because people seem to struggle a little with those. But anyway, new problem. If the domain of f of x is all reals and its derivative is given by f prime is x plus 2 quantity x minus 5 squared over 1 plus x to the 4th, which of the following is true? So this is the derivative, which is nice, except option 3 talks about concavity, which means I think we're going to have to find the second derivative, and that looks incredibly unpleasant because that's not an easy function to find the second derivative of, but we're going to do it. So first I'm going to do a sign chart for f prime. So f prime. And on this, we're going to put -2 because that's a 0 in the numerator, 5 because it's a 0 in the numerator, and there are no real zeros at the denominator, so we're good. Now we got to test region. So if I plug in -1 billion, I get a negative times a positive over a positive. That's 1 negative. So negatives. X plus 2 comes from, or x plus 2 is to the first power. So at the 0 of that, -2, you're going to get a sign change. So this will be plus, or you can just plug in 0 because it's between -2 and 5. If you plug in 1 billion, you're definitely going to get positive. All right, so based on this, f of x is decreasing on -infinity to -2. That is definitely true. F of x has a relative minimum at x equals 5. At x equals 5, there's no sign change of f prime, so there's not that, so that's false. And then concave up, no, down, either one. We got to do this. So I'm gonna do it down here because I think I need a lot of space. So f double prime of x. What's nice is I don't need to simplify it. I just need to plug in 4. So I don't know. We have that going for us. Let's do it. Bottom. Derivative of the top. So that's going to be x plus 2. We got to do a product rule. Times 2 x minus 5 to the first. Plus x minus 5 squared times the derivative of x plus 2, which is just 1. So that was bottom times the derivative of the top. Now we got to do minus top. Okay. Derivative of the bottom is 4x cubed. And it's all over the bottom squared. 1 plus x to the 4th squared. All right, now I got to try to plug in 4 and see what happens. So this will be positive for sure. This middle thing here, I think I need to work out. It'll be 6 times 2 times -1, and then plus 1, right? Because I'm plugging in 4. So that's definitely negative, like this whole quantity here. And then, so now I'm hoping that this is positive, so I can just move on with life. This is positive, positive, and positive. All right, so we have a negative minus a positive, which is negative, over a positive. F double prime of 4 is definitely less than 0. So concave down for sure. True. Whew. Okay, so that was pretty bad. Let's look at this next one. which does not look anywhere near as bad. At which of the marked points above is it definitely true that f prime is less than f double prime? So definitely true. So we're looking for like the best possible answer. I'm just gonna sweep through here and say what f prime and f double prime, what their signs are, and hopefully that'll do it. So at point A, the function is decreasing, so f prime is less than 0. We're concave down, so f double prime is less than 0. We can't really clearly establish the relationship there, so I don't think that's the answer. At B, f prime is less than 0, definitely, because we're decreasing. But we're concave up, so f double prime is greater than 0. So it is definitely the case that f prime is less than f double prime here. So this is definitely an answer, but maybe C also works. At C, you're increasing, but concave up, so that is not an answer. So I think that the only answer is B. All right. Let's look at that, by the way, in case you didn't see it. That's that second derivative that we found. Didn't need to simplify it, which is nice. All right, the graph of f prime, the derivative of f is shown. This is the graph of f prime. Big fan of labeling that because you really got to be on top. Which of the following is true? All right, so we got to go through all of them. F is decreasing at 3. So 3 would be here. F prime is decreasing, but f prime is greater than 0, which means that f is increasing. This is false. F has a point of inflection at x equals 4. So since f prime has a relative minimum, f does have a point of inflection at x equals 4. So this is true. F has a local minimum at x equals 6. I think that's probably a typo. I think this is probably supposed to say f has a local maximum, which would make it a better wrong answer. There's no scenario I could conceive of where you think that there's a local minimum at 6. If this had said maximum, it would still be false, but I could imagine people going for it. This is the graph of f prime, not the graph of f. So no. And then f is increasing at x equals 7. So 7 is here. F prime is decreasing, but since f prime is positive, f of x is increasing. This is true. So that's our answer. Okay. Not a bad problem. This next one's going to be calculator. So we want to find the slope of the line tangent to the graph of f of x equals 3x to the 5th plus 4x squared minus 2 at its point of inflection. So the first thing we need to know, or something we need to know, we're going to need to know when f double prime of x equals 0 and has a sign change. But if you think it through, it's like f is 5th degree, f prime is 4th degree, f double prime is 3rd degree. So there's going to be a 0 where there's a sign change. So I'm going to switch over to, and then after I find that, I need to find f prime of whatever that value is. So this will give me some x value, and then I will find f prime of that x value. So let's switch over so that we can find that. All right, so where's my calculator? Calculator, here you are. I need the second, I'm going to store f of x. F of x is 3x to the 5th plus 4x squared minus 2. I'm not sure what minus 2 is doing there. Like, it's not doing a lot. All right, so I want to solve menu 3, 1, and I need the second derivative with respect to x of f of x, because I'm looking for the point of inflection, equals 0 for x. Oh, man. Let's get a decimal. So negative 0.511, let's say. And now I'm looking for the slope of the line tangent to the graph. So that's just the derivative. So I'm going to do derivative at a point. Menu for derivative at a point. X is my variable. I'm just going to like type 1 here, and then I can change that in a second. So I want f of x, and then this I'm going to change to this value and get an answer. So f prime of negative 0.511 is approximately negative 3.065. That is the slope of the tangent line. Let's go back to the problems if I can remember how to do that. Here goes. Okay, so I've written this. So there you go. That's not a bad problem at all. 43. A function is defined so that it has first and second derivatives shown below. On what interval or intervals is the graph of f of x both decreasing and concave up? As you can hear as I read the problems, you can kind of like get a sense. I'm not good at reading, I guess is really what it is. Increasing, decreasing, and concave up, down. I like just confuse them. And that's a problem. I don't confuse the concepts. I confuse literally the words when I read the words. It's the worst case scenario. All right, f prime has zeros at -3 and at 0. And then f double prime has zeros at 0, -9/4, which is like -2.25. So let's put that here. All right, and now we're just gonna fill in our sign chart, right? So on this interval, -1 billion will give me a negative and a negative, so overall positive. And then since this comes from this, which is to the first degree, there will be a sign change. And then since this comes from this, which is third degree, there will be a sign change. Or you can plug in a billion. And then we got a test on this one. So -1 billion, positive, negative. So negatives all the way through, so you can clearly identify a region. This comes from this first degree, going to be a sign change. And then the 0 comes from x squared, no sign change. All right, decreasing and concave up. So decreasing concave up is going to be like this region, right? Because I need f prime to be negative, I need f double prime to be positive. So decreasing concave up on -9/4 to 0. That's a good problem. And then if we had to justify, we would say because f prime is less than 0 and f double prime is greater than 0. But I'm not justifying on these, I guess, apparently. All right, 44. If the graph of y equals x cubed plus ax squared plus bx minus 8 has a point of inflection at 2, 0, what is the value of b? So this point is doing two things for us. It's telling us something about the function. Like I know if I just plug 2 in, I'll get 0. So let me do that. So the point 2, 0 gives me 0 equals 8 plus 4a plus 2b minus 8, which means I'm going to say 2a plus b is 0. Is it like 4a plus 2b equals 0? But, you know. So that's the first thing it does. The second thing it does is it tells us the second derivative at 2 is also 0. So let's find y prime is 3x squared plus 2ax plus b. Y double prime is 6x plus 2a. So y double prime of 2 equals 0 means that 0 is 12 plus 2a. So a is -6. And then if a is -6 and 2a plus b is 0, that means -12 plus b is 0. So b is 12. And that is our answer. That was a good problem. That was pretty straightforward. That was better than those tangent line problems that we did ages ago in this video, but ages ago. Given that f of x is the function above, for what values of x is f of x concave down? So we got to find the second derivative. So you could jump in with the quotient rule here, but I think you're going to go crazy if you do. I think a better move is to write f of x as two separate things. So x to the fourth over x squared is just x squared. And then minus 27 over x squared, I'll make it minus 27x to the negative second. The reason for that is I can now pretty easily just use the power rule. 2x and then plus 54x to the negative third. And then f double prime will be 2. Well, this is unpleasant. Minus 162 x to the negative fourth. Okay. Am I going to be able to solve this? I don't know. Okay, so that is going to be, what am I doing? I'm going to do 2 minus 162 over x to the fourth, which is 2. Let's do that. X to the fourth minus 81 over x to the fourth. Okay, joyous. So that's f double prime. I think I can keep going here. F double prime is 2. I'm going to make it x squared plus 9, x squared minus 9 over x to the fourth. And then finally, f double prime. Finally, as if I didn't, I'm going to need to do a sign chart. X plus 3, x minus 3, all over x to the fourth. Whew. Okay. So what's kind of interesting is our sign chart really only depends on x plus 3, x minus 3. Because x squared plus 9 has no real zeros, and x to the fourth is 0 at 0. I mean, I do need to worry about that, except 0 is not in the domain. Well, I still need to worry about it. It needs to go on the sign chart. So here goes, sign chart. So I'm going to put -3, 0, because it's not in the domain and things can happen there. And then 3, this is for f double prime. So if I plug in negative a billion, I get negative, negative. So positive. This is going to do the same thing as a quadratic, basically. If I plug in, I don't know, -1, let's say, I get, so I'm plugging in -1. This is always positive, positive, negative, positive. Only one negative, so negative, as expected, but whatever. There's not going to be a sign change at 0 because it comes from x to the fourth, but I'm going to plug in 1. So that'll give me positive, positive, negative, and positive. So only one negative. So still what I was expecting. And then a billion, you can just see, is going to give you positives. So concave down for -3 to 0, and then 0 to 3. All right. How many questions are there? 49. Can I power through? I guess so. Let's keep going. This one's calculator. F of x is sine of x times natural log of x, and we just need to know if f of x is increasing, decreasing, or f of x does not exist. 5 pi over 4 is definitely in the domain of both. I wonder if it was supposed to say f prime. There's no way to know. But anyway, c is ridiculous. So let's do this. We want the derivative. So I'm going to use that shortcut, shift, and then minus of sine of x ln of x. Oh, I really wanted to evaluate this, but I'll just get that and then do such that x equals 5 pi over 4 and control enter. So I got negative, so f prime of 5 pi over 4 is less than 0, therefore decreasing. That was a pretty straightforward one. Going back to this. So if less than 0, so decreasing for sure. I don't know. Sometimes you get questions like that, right? They have to assess if you know all of it, not just the challenging parts. And it was calculator. So if we needed to get the derivative by hand, which I think is a reasonable question, it would have been first derivative of the second plus second derivative of the first. So that's if you had to do it by hand. The reason the calculator gave a warning that I completely ignored is that the domain of the derivative might be different from the domain of the original, and the calculator will warn you about that constantly. In this case, it's not, I don't think, because the natural log is still there. Natural log has a domain of x greater than 0. 47. If the slope of the curve, gonna make this small. If the slope of a curve at all points xy is x plus 2 to the fourth times x minus 5, then at the point where x equals -1, the curve has a, I have to do a sign chart. Why point of inflection? Why does that have to be an option? I have to find the second derivative again. So this is dy dx, or y prime. So y prime is x plus 2 to the fourth. Unless, so at x equals -1. anything happen at this? That's the slope. Why would it be at -1? I think it's supposed to be at -2. I don't know. I mean, if it's at -1, then 1 and 2 are both clearly wrong because there's no way there's a horizontal tangent. There's no way there's a relative maximum. I want to change it so that it's -2 because that is more interesting, and so I'm going to do that. All right, that's our new problem. So at -2, I'm going to do a sign chart, even though you can I think you can probably see what's going to happen there. So for y prime, -2 goes on and 5 goes on. -1 billion gives us negative. So this -2 is from a 4th degree thing, so there will not be a sign change. So negative. So there's not a max or a min. There is a horizontal tangent line because y prime of -2 is 0. So this is right. There is a horizontal tangent line. There's not a relative maximum because there was not even a sign change in the first derivative. Point of inflection. I think there will be a point of inflection. We got to find the second derivative to know that though. Y double prime first derivative of the second plus second derivative of the first is 4x plus 2 cubed. Okay, and we can factor that. I'm going to take out x plus 2 cubed, which leaves me with x plus 2 from the first thing, and then 4 times x minus 5, so 4x minus 20, which means this is x plus 2 cubed, 5x minus 18. Okay, sign chart for this. Although I think, you can probably, I think you can look at this and know that there will be a sign change in y double prime, -2. Because everything is an odd power, there has to be a sign change. And if there's a sign change in y double prime, there is a point of inflection. So there is for sure a point of inflection, but I don't know why I'm doing this anyway. -1 billion gives me negative, so plus, I don't know, 0 would give me plus minus, and then 1 billion will give me plus. So there are actually 2 points of inflection, but the question that we modified is only about -2. There is a point of inflection, so the answer is 1 and 3. That ended up a good question. It started out a bad question, but that's what you got to do, because I am the only one that reads over the problems that I write before I try to solve them, and sometimes it doesn't go well. This is calculator. Given that f of x is 3/2 x cubed, and g of x is 2/3 x to the 4th minus 5/2 x squared plus 6, only on the interval from 1 to 3, at what value of x is the vertical distance between the curves at a maximum? The vertical distance between the curves. So the vertical distance between the curves, I'm going to call it like h for height between them, I guess, would be the absolute value, because I don't know which is on top, of f of x minus g of x. And I'm looking for the maximum of that. So I need to find h prime, I guess. I don't like this question, but that's what I need to do. H prime of x. This is a calculator question, though. Nobody wants to do that by hand. So let's go back. And I'm going to put in a new problem doc, 4 and then 1. And I guess I'm going to define f of x and g of x and then h of x. It's my plan. G of x. And again, I apologize that this sounds like crazy banging on keys. I'm not really banging them as hard as they sound like I am, but it comes through. I don't actually know where the microphone is on this, but it's like right under the keyboard seems to be the answer to that. All right, so h of x is the absolute value of f of x minus g of x. That would be the vertical distance between them. So I'm going to do this by graphing, I think. I'm going to graph the derivative of h of x. I mean, like, this is a bad question because, like, well, I'm writing derivative. You can still use the shortcut here, shift minus h of x. Let's see. Hopefully this doesn't crash I think it probably crashed the calculator. Oh, maybe not. Maybe. I definitely don't see anything. Where are you? All right, I don't see it. Oh wait. Darn it. Darn it. You know what I should have done? Should have changed the window. Let me do that. Let's change the window so that it only goes from 1 to 3. It's like overtaxing the calculator. Oh, what is this? Why? It's not, I guess it's not differentiable at some point in there. That's really interesting. And you're going from decreasing to increasing. Huh. Okay, so our only candidate, so if you're going from so this is the graph of the derivative. So the derivative goes from negative to positive at whatever this thing is. So that's not going to be, that's a relative minimum. There's a 0 here, which hopefully we can find. So the answer is either going to be this left endpoint, so at 0, or at whatever this critical point is. So let's graph 0 and see if we can find the intersection here. Menu 8, 1, 4. Click. It really hates this. Click. Puzzling. This is absolutely puzzling. I do not know what this point is. Ignore that. That is clearly an error. So what's happening there, I'm going to graph h of x when I'm done with this. What's happening here is that there's a sharp turn, which means that h of x is not differentiable at that point. You go from decreasing to instantly increasing. There's no like transition. But 2.45, I'm going to store this as, I'm just going to store it as xc, the x coordinate. And then at 0, so if you think about it, the absolute minimum at maximum, I guess, is occurring at an endpoint or a critical point. So in our case, it's either at an endpoint or a critical point where the derivative goes positive to negative because we're looking for a maximum. So if I do h of 0, and if I do h of the x coordinate that I found, it looks like the maximum is at that value, which I did not write down. So what am I gonna write here? Equals 0. I don't know. 2.452. So I'm gonna go back to the written part in a second. Let me just graph h of x. Graph h of x, and then I need to graph it only on the interval that we're interested in. So 1 to 3. Yeah, there it is. That's that like that non-differentiable place. Obviously, it's not a maximum, but really interesting. And then if we kind of move that a little bit, you can see there's our maximum for sure. So this is an interesting problem. Let's go back to write this out. Who knew we were going to have such an interesting problem? So this was the only 0. There is the discontinuity. So I'm just going to say absolute max at an endpoint, or let's say relative max. So then what are we looking at? What value of x? So therefore the absolute max is at x is approximately, I think it was 2 point, what? I think it was 2.452. Right, and what I really should have done was found h of 1. Oh, I didn't find h of 1. I found h of 0, I think. But this is what we were comparing. 2.452. I kind of want to go back and make sure. No, we saw it. That was definitely the maximum. Overall, not a good showing by me on this problem, but like that's the general idea. All right, and then question 49, which is actually the last question. Thankfully, maybe? I don't know. I've been working on this for a long time. If f of x is the natural log of x squared plus k times x to the 1/3, f of x has a relative maximum at x equals 8. So, I mean, one thing we know is that f prime of 8 will be 0 or not exist. Then what is the value of k? So let's see. What's f prime? F prime is... So it's actually easier if you think of the natural log of x squared as 2 times the natural log of x by using properties of natural logs. So then it'll just be 2 over x. and then plus 1/3 k x to the negative 2/3. This doesn't seem easy to solve. Okay. So, oh no, what are we doing? We're doing f prime of 8 equals 0. So this is not as bad as it seems. So f prime of 8 equals 0 means that 2 over 8, which is 1 over 4, plus 1/3 of k, 8 to the negative 2/3 is equal to 0. So 1/4 plus 1, God, I can't make 3's anymore. 1/3 k. This is, the cube root of 8 is 2, squared is 4, to the negative first is 1/4. Okay, so what am I doing? I don't really know. I'm gonna do 1/12 k is negative 1/4. K is negative 3. I got k is negative 3. I believe that to be the value of k. All right. That was quite a few calculus review problems. I don't actually know how to end this. I hope you found this helpful, and good luck.